All right, welcome back to our Project Euler series. Last time we did problem 3 of Project Euler. Let's move on to problem 4. So where were we? We'll need to create another case in our mapper. This will be problem 4, and let's just head on to Project Euler and see what the problem is. So this is our problem, largest palindrome product. A palindrome number reads the same both ways. The largest palindrome made from the product of two-digit numbers is that find the largest palindrome made from the product of two three-digit numbers. So the largest two-digit numbers, which when multiplied gives a palindrome which reads both ways. This is the result for that. We need to find the same thing for three-digit numbers. So uh, this should be pretty simple. Palindrome product, input int, we give out an int, you just return 0 for now. We will set up our palindrome product here, and let's just set up the tests as well. So copy and paste that real quick. Palindrome product. So this will be our input. We will be giving the input. Our input will be the number of digits we are looking for, the product of two n number of digits, like n digit numbers, sorry. So this will be our input. So in the case of two, so like the largest, uh, so the palindrome product of the two-digit numbers, the largest one would be 9009. We don't know what the answer is for three-digit numbers, so we'll just let it be as 0, and we'll just call it palindrome product from there. Make sense? So let's just implement our function real quick. If you think about this, this is just a nested for loop that we need to run for, let's say, if the input is 2, then we will be running a for loop from 99 to 10, including 10. And we will be running another for loop from 99 to 10, and we will be seeing, we will get the product of I times j, where let's just assume that, and I'm just writing the pseudocode for now. Uh, this makes a lot more sense. So we get the product, we check if is palindrome P, and if it is a palindrome, then we just return P, or else we return 0, which I don't think will happen. We should get a palindrome at least once. So we need to generate whatever input we have, we need to generate that many nines. That would be step one. So we can like create a function for that. We would call it something like niner, which will give us the input number of nines. We can also have this input -1 because we had it at so we'll do something like this where input is greater than that. I'm sorry, I is greater than that, I plus plus. Same thing for this. We don't have the function yet, but we are using it anyway. Uh, j greater than, oh, we need to do j minus minus. Forgot about that. Yeah, this makes sense. And we'll just create a, so it'll do something like that where it'll return whatever the input we received, it'll return that many nines. But here's the problem. We are looping from 999. Let's say if the input is 3, then we're looping from 999 all the way to 100 here. And we're looping again from 999 all the way to 100. And let's say in the first iteration, we have 999 as I, so I would be that, and j would be j would go over all the values from 999 to 100. And I think like if we went from 999 to 100, we wouldn't get our maximum palindrome right away. So what we can do is instead of uh, doing like, yeah, so instead what I'm thinking we could do is go from 999, like instead of doing this, instead of on each iteration we go from 999 to 100, we could go to 999 minus 100 from 999. So we go to like 899, and this increases our probability of instantly getting the maximum palindrome, and this should work like that should give us our max palindrome. So we will get, instead of doing this, we will do something like this where we do maths dot power 10 of the input minus 1. This should work. So let's say if this is 999, then this would be 100, uh, because we are doing 10 power 2, which should be 100. And to get the product, which should be I times j. Now we need to implement is palindrome as well. So similar to our niner, we'll just create a dummy is is palindrome method. Oh yeah, this palindrome should return a boolean, a bool value. All right, now we have a pseudo code for our whole solution. Now we can like go on to our utils, create a palindrome.go and paste in our dummy functions. Now we need to implement this stuff. To check if something is a palindrome, especially if it's an integer, first we'll need to convert it into a string, reverse it, and compare both of them. That would be our Boolean. So to convert something into like to convert an integer to a string, we should have something here. So that is ASCII to integer. We need integer to ASCII. Yeah, that should work. So we are converting that, and we return. So this is our string int, and we return string int. Is it equal to reverse? Now, how do we do reverse? We'll probably need to implement reverse ourselves, and it'll give another string out. And let's think how we can do this. So we can have two pointers uh, for ij 0 to. We'll need to initialize an empty row here. So row string equals. So let's see. Now we've initialized our runes array, our rune. If you work with uh, languages which have characters, then a string like this is basically an array of characters. This is what we've done. So we'll initialize two variables here. One would be at 0, the second one would be at the length of our rune string. Isn't that working? And we do this while I is less than j, and I comma j equals I plus plus j minus minus, and What's the issue here? Okay, we'll need to write it like that. Uh, so we're setting I and j to I plus 1 and j minus 1. So if you don't see what we're doing, we are initializing I as A at A's position and B at C's position. And at each step, we are moving our pointers one step towards each other. And we do this while I is less than j. And at each step, we set our rune string I rune string j as this. So we're replacing whatever is at position I with position j. So if we had this as our string and I was at position of A and j is at position of B, I'm sorry, at position of C, then the first step we would uh, swap A with C, and our string would now look like this. And that next step we would move I and j with by one step, in which case they will both be at this, and this condition would become false, and this would be our result. And the same thing would happen if we had larger strings as well. So let's just return our rune string, convert it into a string. Now, okay, it should be string in here. So this is our is palindrome function. Coming to our niner function, let's see. So we need to have an initial int value, and we need to loop through 0 to the input I plus plus, and at each step we need to modify nines by uh, like we get the power 10 of whatever I we have right now. We multiply it by 9 and we add it on to our nines. So in first step, this would be 0. So the power of 10 to the 0 would be 1. We multiply it by 9, we get 9. We add it on to nines. So right now the value of nines is 9. Second iteration, this would be 1. So the power 10 to the 1 would be 10 times 9 would be 90. Add it on to 9, we get 99, and so on. So at the end of this loop, we should have the number of nines we require. Awesome. So we need to start using our utils now. This way, all right. Now if we try to run our, uh, have we set this up? Yeah, we did. Now we can run this with 2 and 3. Uh, problem. Yeah, so we run it with 2 first. I had a typo there. Okay, I think our niner, this thing has an issue. Yeah, so we're initializing j to the length of room. We want it to be that way. So the length minus 1, that would make more sense. Oops, I have 999 hard coded here. We need to remove that. Okay, here, getting our answer back. Let's try it with input 3. 906609. And that is the answer we were looking for. Cool. So our solution works. Uh, let's go to our solution test and modify this. So our 906609 and make test, and we see everything passed. Awesome. So thanks for watching this one. See you in the next video of Project Euler.